The three operators we just looked at, concatenation, alternation, and zero or more repetitions, are fundamental, right? Those are the operators that make up what a regular expression fundamentally is. But it turns out there are some other patterns that can be expressed in terms of those three things. So we can think of these as sort of higher order operators that aren't necessary to the concept of regular expressions. There's nothing new we can express with what we're about to see that we couldn't express before. However, they cover scenarios that are so commonly useful and have such wide application that we're going to extend the operators in ways that's done traditionally in many different environments. So not only will the grep with our E flag make use of these extended operators, but if you're writing regular expressions in a programming language like Java, JavaScript, or Python, they're all going to have these additional operators as well, because they're just so handy to have built into a regular expression engine. So the first one we're going to look at is a character class, and this is a list of characters, right? So if we imagine defining a regular expression R as A or B or C or D or E or F, right? So the single characters A through F, we could do so like this. Well, with a character class, it's some special annotation that means the exact same thing, right? So within a set of square brackets in a regular expression, what we'll see is we can place individual characters, and we mean that any of those characters can match, right? So we're saying A or B or C or D or E or F, the same as what was expressed above is being expressed down here below. And this is often useful when we want to look for a regular expression that matches punctuation, right? So we could have in our character class, and so that's what we're defining here, these square brackets we'll call a character class, and we could have comma or period or colon or semicolon, right? And so if we wanted to, we can also have ranges of characters, because we've learned earlier in the semester that ASCII tends to put characters one after the other in meaningful ranges, right? So A is followed by B is followed by C in ASCII. So similarly, we can specify ranges in our regular expression character classes to say, hey, match any character A through Z, right? And again, the explanation for ASCII is down below. Similarly, we can specify ranges, so this would match a hex word, right? So A through F, lowercase, or A through F, uppercase, or 0 through 9, right? So within a character class, if you specify a range, it's independent of anything else you specify, and anything else is ORed in here as well. So it would match any of those, right? So let's try finding words that we can make with only the letters of a hexadecimal, right? So if we try this, oops, I'm going to clear my screen, and let's try words that I'm going to use the start of word anchor here, and we'll use A through F, for example. Actually, let's try and do this explicitly first. So A, B, C, D, E, F, and we'll use the asterisk to say 0 or more repetitions of this, and all the way to the end of the word. So words that we could spell with only the letters available to us in ASCII include decade, decaf, ebbed, efface, fade, faded, feed, beef, I think would be one of them. Yep, there's beef, so on and so forth, right? So that makes sense. And so what we're saying here is, with this regular expression, starting from the beginning of the line, we want to match 0 or more of any of these letters, followed by one after the other, all the way to the end of the line. If we didn't include this end of line anchor, right, we would have matched everything, because then we would have had words that had 0 matches of any of those letters, and that counts too, right, because of the cleaning star, right? So if all we're doing is the cleaning star operator and we want to match some pattern, it's often useful to specify the anchors for start of line, end of line, as we saw here, right? If we wanted to include, so now we can prove to ourselves that we'll get the same output if we use a character class range, right? So the A through F gives us that. If we wanted words that were only, let's say, M through Z, we would have words like wow, your, zoom, worm. And so we can prove to ourselves that that works just the same, right? So words that only contain letters in the range of M through Z. Now think about how much we would have needed to type out. We would have needed to do something like, if we didn't have this character class annotation, we would have needed to do M or N or O or P or Q or R, so on and so forth, right? But because we have this extended regular expression syntax for specifying a character class, we can say M through Z, and that's pretty handy, right? You can imagine if you're trying to write an expression to match numbers, 0 through 9 is also really nice to have available, like we saw in that example. Right? When we're using character classes, it turns out we can, without needing to escape, and we'll talk about escaping in just a moment, without needing to worry about their other meanings in the regular expression, we can use the asterisk, the open curly, the closed curly, and the or, right? So we're treating those as matching those as character literals, right? So this regular expression would match a star or an open parenthesis or a vertical bar. However, what if we wanted to match the square bracket character? Well, we would need to escape that character. And the specific way that you would escape using a square bracket, like if you're trying to write a regular expression that uses a character class and matches against square brackets, just look up in your library how it is you would do that. But typically you're just going to put a backslash in front of it. All right? So the next extended syntax we're going to learn is N to M repetitions. Right? So these are numbers of repetitions we want to match. So imagine we have a definition that is going to match 2 to 4 repetitions of some regular expression. We could have R concatenated with R, or 3 in a row, or 4 in a row, right? Well, with this new syntax that we're adding to our idea of regular expressions, we can say, take the regular expression R and match N to M repetitions of it. So 2 to 4 repetitions of it, right? We can leave one of these characters out to say at most M repetitions. This would be 0 inclusive. So this is like the Kleene star, but only up to a certain number of repetitions. So this would match against 0 repetitions. We can say at least N repetitions. So we could say R N times or more if we leave off the upper bound here. All right. So let's try writing one of these. So if I go back into my terminal, and I would encourage you to join me here. We could do something like A or N, and we want 2 to 4 matches of A or N. And we can see 2 matches, N, A, N. Let's try 3 or 4. And here we get a sequence of 3 ANs. What if we wanted at least 4, but potentially more, right? So 4 or more gives us words like bandana, nannies. Are there any words in our dictionary that have more than 4 in a row? All right, kanan is a word that has 5 in a row. See, 5 in a row for, I'm not even going to try and pronounce that word. And you kind of get the point, right? So this is a very succinct way of writing a specific number of repetitions we want with some upper or lower bounds. And that's something that we could have done with concatenation in the Kleene star and alternation, but it gets very verbose to specify this, right? We'd have to specify AN followed by AN followed by AN followed by AN, and then followed by AN Kleene starred for more than for no upper bounds, right? So there's a way of expressing any of these operators we're looking at in this particular video using only our simpler 3 operations, but boy, do these new operations we're adding to the idea of a regular expression, our regular expression syntax, make our what we can express more robust without a lot of verbosity, right? So the last one I want to talk about is exactly N repetitions. Actually, there are 2 more after this. So exactly N repetitions would be, what if we wanted the range of at least from 5 to 5, right? From n to m repetitions, where we want exactly 5 repetitions of some regular expression. Well, that's pretty redundant. So if we specify just a single number, we'll match exactly that number in a row, all right? If we wanted one or more repetitions, this is very common. We could have done this with the n to m syntax, right? One or more. But this is such a common operation that we have a special symbol for it, which is the plus. So 1 or more is the plus. 0 or more is the star, right? But 1 or more is the plus. So we could try this out. We could try an plus. So 1 or more ans following one after the other. And sure enough, we get an. And if we went all the way up to banana, which is going to be quite a scroll. Let me just try putting a B in front of this to convince ourselves that banana would be an example of a word that would match an twice in a row, right? So that would have matched this, would be a single match against this regular expression where an was repeated, it occurred once and then came one after that. But this would also this would also match ban, so on and so forth. All right. So that's a very common operator that we'll use. We want to say, hey, there's at least one of these things here. And remember, this actually would have worked really nicely with our digits, right? For a whole number, we would have liked to have said our digit plus, right? So one or more digits is what's going to make up a whole number, right? But we didn't have that before, so we had to use the more verbose syntax using the simpler operations we had defined prior, right? So there's a 0 or 1, which indicates this is an optional thing, right? So an optional thing we would often write as R or the empty set. And so empty set would mean match anything, and that would be okay. And so empty string will match against nothing. And this is why when we used the clean E star and we saw that 0 or more would match against anything. Similarly, 0 or 1 will match against anything unless we use it in conjunction with other operations. Right? So this would be the same as using n to m operations where we're matching either 0 or 1. But because it's so useful, we use the question mark as the operator here. So any regular expression followed by a question mark makes this part of the regular expression optional, meaning it'll match 0 or 1 times. This would be commonly used if we were using our digit example. So if we had before our digit and plus would match any whole number that's positive, you could imagine having the negative character, right? So the minus symbol would be optional, and that would allow us to specify either negative or positive numbers with an optional negative symbol in front of it. So we can try this operator out real quick in our terminal. So if we said perhaps grep a followed by n followed by a, but the n is optional. This will match words where we have 2 a's in a row, but also words where there's an n between them, right? And so the 0 or 1 operator is the question mark, and that's a very useful operator for optional, or specifying something as optional in a pattern. The precedence of these operators is important to have some sense of in order to understand how the regular expression engine is going to evaluate it. So the highest precedence are the asterisks and the plus symbol, right? Notice these repetitions are tighter binding or higher order of operations than the concatenation operator. So what do I mean by that? Well, if we don't use parentheses and we have an expression such as the one we just saw, a, n, question mark, a, this is the same as a, n, question mark in parentheses, a, right? A followed by an optional n followed by an a. It's not the same. That's not what's happening. It's not an question mark. And the reason for that is because repetitions, these operators, the asterisk, the 1 or more, 0 or 1, or some specific range, those are the highest order of precedence in our little language here, right? So because this question mark is a higher order of precedence than our implicit concatenations, right? It's as if we had written it like this. Now, if we wanted to, we can use parentheses to be explicit here. And that's generally what I would encourage you to do if you're writing regular expressions. Rather than rely on these precedences, try and use regular expressions in a specific way, or sorry, try and use parentheses in an intentional way. So I would probably have written this in this way to make it very concrete and obvious, even though this is a little bit redundant, right? We didn't have to have those parentheses there. That is the same as this. Right? The lowest order of precedence is the alternation, right? So if we had a, n, or a, because this or is a lower precedence than concatenation, that's the same as saying a, n, or a, right? And so the or is lower precedence than concatenation. So because there's a concatenation operator over here, that's going to be evaluated first.